Somewhere outside of Birmingham, England, a retired schoolteacher named Margaret Hobbs did something that her neighbors called eccentric, and her daughter called a complete waste of time. She took a roll of copper wire she found in her late husband's garage, cut it into small rings about the width of her thumb, and buried one next to each of her tomato plants. That was in April. By August, her tomatoes were nearly twice the size of her neighbors. Her courgettes had overtaken the raised bed entirely. Her runner beans had climbed so high she needed a ladder to reach them. Margaret didn't have a chemistry degree. She hadn't read any scientific journals. She'd found a single paragraph in a gardening book from 1987 that mentioned copper, and she'd decided to try it herself. She told no one what she had done, but her garden told everyone. Here's the thing. Margaret isn't alone. Across kitchen gardens in Wales, homesteads in rural Tennessee, urban allotments in the Netherlands, and permaculture plots in New South Wales, ordinary people are quietly burying small copper rings in their soil and watching something happen that mainstream horticultural advice has never once suggested they try. The question isn't whether it works. Enough people have watched it work with their own eyes to make that argument increasingly difficult to sustain. The real question is why nobody in the gardening industry is talking about it. Why the seed companies aren't promoting it. Why the garden centers aren't stocking copper rings on the shelf next to the slug pellets and the tomato feed. And when you follow that thread, you end up somewhere a lot more uncomfortable than a conversation about gardening. To understand what copper does to a living plant, you first need to understand what copper has always done for living things. Copper is one of the oldest tools in human history. The Copper Age, which historians place roughly between 5000 and 3000 BCE, wasn't just an era of weapons and cookware. The ancient Egyptians used copper compounds to sterilize water and treat infected wounds. Sanskrit medical texts written over 4,000 years ago describe copper vessels as essential for purifying drinking water. The Romans lined their aqueducts with copper fittings, not for structural reasons, but because they noticed that water carried through copper pipes stayed cleaner, longer. They didn't know why. They just knew it worked. What we know now is that copper is oligodynamic, meaning it has a natural toxic effect on bacteria, fungi, viruses, and other microorganisms even at extremely low concentrations. When copper ions come into contact with a microbial cell wall, they disrupt the membrane, interfere with the cell's enzymatic processes, and cause the cell to die. This isn't a chemical reaction that requires an outside catalyst. It happens naturally, continuously, as long as copper is present. Hospitals have quietly known about this for decades. Studies published in medical journals have shown that replacing standard steel and aluminum surfaces in intensive care units with copper alloy surfaces reduces healthcare-acquired infections by over 40%. Some of the most infection-prone environments in the world, the bed rails, door handles, and IV poles, are now being fitted with copper components in forward-thinking hospitals across the United States and Europe. The science is not new. It is not fringe. The antimicrobial and antifungal properties of copper are among the most rigorously documented phenomena in all of material science. And yet, when you walk into your local garden center and ask someone about copper and soil health, most of the time you will be met with a blank look. That disconnect between what the science clearly establishes and what the commercial gardening industry chooses to promote is where this story really begins. Let's talk about what happens below the surface when copper enters a garden ecosystem. Because this is where most of the misinformation lives, and it's worth taking the time to understand it properly. Copper is what soil scientists call a micronutrient. That means plants need it in very small quantities to function, but they absolutely do need it. Copper plays a direct role in photosynthesis. It is a component of plastocyanin, a protein that moves electrons through the photosynthetic chain in chloroplasts. Without adequate copper, plants cannot efficiently convert sunlight into energy. The process that sustains virtually all life on Earth runs partially on copper. Copper is also essential for cell wall formation in plants. It supports the synthesis of lignin, the compound that gives plant stems their rigidity and their resistance to physical damage. Plants deficient in copper show characteristic symptoms: twisted young leaves, wilting despite adequate water, pale or bleached new growth, and a general failure to thrive that is often misdiagnosed as nitrogen deficiency and treated with more fertilizer, which does nothing to address the actual problem. Copper deficiency in agricultural soils is more widespread than most gardeners realize. Decades of intensive farming, heavy irrigation, and reliance on synthetic NPK fertilizers have stripped many soils of their trace mineral content. NPK stands for nitrogen, phosphorus, and potassium, and those are the three elements that most commercial fertilizers deliver in abundance. What they don't deliver is copper, zinc, manganese, iron, boron, or any of the other micronutrients that a living soil system requires. There's also the fungal dimension, and this is where copper rings become particularly interesting. One of the most common causes of poor plant performance in home gardens isn't nutrient deficiency in the traditional sense. It's root zone fungal load. Soil-borne fungi, including species of Pythium, Fusarium, and Rhizoctonia, colonize plant roots and interfere with nutrient uptake. A plant struggling with root fungal pressure may have perfectly adequate nutrition in the surrounding soil, but be unable to access it properly. Growth slows. Flowering is delayed. Yields are reduced. This is the point where a small copper ring, buried an inch or two below the soil surface, near the base of a plant, starts doing something measurable. As copper oxidizes slowly in contact with soil moisture, it releases a continuous, extremely low-level stream of copper ions into the surrounding soil environment. The concentration is far too low to harm the plant itself. It is, however, sufficient to create what you might call an unfriendly environment for the fungal pathogens that compete with and parasitize plant roots. The copper doesn't kill every microorganism in the soil. That would be catastrophic. It acts with a degree of selectivity that scientists are still working to fully characterize. But the practical effect observed by gardeners again and again is that root zones treated with small copper sources show healthier root development, faster establishment, and in many cases, visibly accelerated above-ground growth. Margaret Hobbs didn't know any of this when she buried her copper rings. She just knew what she saw. Here is where we have to be honest about the limitations of what we know, because this story, if it's going to mean anything, has to be told straight. There is no large-scale, peer-reviewed, double-blind clinical trial on the effects of small copper rings on home garden plant growth that you can pull up in an academic database. That gap in the literature is itself part of the story, and we'll come back to it. But the absence of formal studies doesn't mean there's no evidence. It means the evidence exists in a form that the scientific establishment hasn't yet chosen to investigate. What we have instead is a growing body of observational data from home gardeners, documented comparison trials run by individual growers, and a smaller number of more structured experiments conducted by gardening bloggers, YouTube channels, and permaculture educators who decided to run their own controlled tests when the official research failed to appear. A gardener in Oregon named Clint Dixon ran what he called a side-by-side trial across 2 growing seasons. He planted identical varieties of courgette, tomato, and beetroot in identical raised beds with identical compost and watering schedules. In one bed, he buried copper rings made from standard electrical wire, cut to roughly an inch in diameter, near the base of each plant. In the other bed, he used nothing. He documented everything with photographs taken at weekly intervals. By week 6, the differences were visible enough that he repeated the trial the following year with additional controls, adding a third bed treated with a copper-based liquid fungicide spray to compare the effects of surface applied versus soil buried copper. His conclusion, published in a series of posts that accumulated over 40,000 views, was that the buried copper ring beds consistently outperformed both the control bed and the spray-treated bed in terms of growth rate, fruit set, and overall vigor. A homesteader in rural Shropshire ran a similar trial with strawberries and documented that copper ring plants produced runners earlier, rooted faster, and produced larger first-year fruit. A community garden project in Auckland, New Zealand, incorporated copper rings into their new allotment beds as a matter of standard practice, after several plot holders reported consistent results across 3 consecutive seasons. None of these people are scientists. None of these trials meet the evidentiary standard required for publication in a peer-reviewed journal, and that is a completely reasonable objection. But here's the counterpoint. A great deal of what the commercial gardening industry sells has also never been subjected to rigorous independent testing. The proprietary root stimulants, the bioactivator granules, the mycorrhizal inoculants that come in foil packets and cost 12 pounds for a small jar. Many of these products have thinner evidence bases than the accumulated observational record behind copper rings. The difference is that they have marketing budgets, retail shelf space, and a distribution network. A 1-inch piece of copper wire costs nothing and can't be sold. This is the section that tends to make people uncomfortable, because it requires thinking about the gardening industry, not as a collection of plant-loving enthusiasts sharing knowledge in the public interest, but as what it actually is, a multi-billion-dollar commercial sector whose revenue depends on gardeners continuing to buy products. The global garden products market is worth over $100 billion annually. That number includes seeds, tools, and infrastructure, yes, but a substantial portion of it is consumables. Fertilizers, pesticides, fungicides, plant feeds, root stimulants, soil improvers, compost activators. These are products that gardeners buy repeatedly, season after season, year after year. Their value to retailers and manufacturers depends entirely on gardeners needing them continuously. A solution that costs nothing, never needs replacing, works passively in the soil for years as the copper oxidizes slowly and requires no specialist knowledge to implement, represents something the commercial gardening industry has absolutely no financial incentive to promote. This isn't a conspiracy. It doesn't require boardroom meetings or coordinated suppression. It's something much simpler and much more pervasive. A structural incentive that shapes what gets funded, what gets studied, what gets advertised, and what gets recommended by the same gardening publications and influencer accounts that are sponsored by the companies selling the products you're being encouraged to buy. Consider the reach of copper-based fungicides in commercial horticulture. Copper sulfate, copper oxychloride, and copper hydroxide are used extensively in organic and conventional farming as approved fungicidal treatments. The evidence for copper's antifungal efficacy in agricultural contexts is so solid that it forms the backbone of organic certification standards in multiple countries. French wine producers have been applying copper sulfate, known as Bordeaux mixture, to grapevines since the 1880s, and it remains one of the most widely used treatments in viticulture globally. The science supporting copper as a plant protectant is well over a century old. It is not disputed in any serious agricultural or horticultural context. But the commercial formulations in which this copper reaches the market are proprietary. They have brand names, packaging, dosing instructions, and profit margins. The copper ring you cut from electrical wire in your garage has none of those things, and therefore none of the infrastructure that would bring it to the attention of the average gardener exists. There is also the question of soil health narrative. The dominant commercial framing of garden soil over the past 50 years has treated it primarily as a growing medium that needs to be continuously supplemented with inputs purchased externally. Buy this feed. Add this amendment, spray this treatment. The premise underlying almost all commercial gardening product marketing is that your soil is inadequate and requires correction. the alternative framing, which has been slowly gaining ground through the permaculture movement, the no-dig gardening community, and the broader sustainable self-reliant space, is that healthy soil is a living system that, given the right conditions, can largely provide for itself. That framework leads to very different gardening practices, almost none of which generate reliable commercial revenue. Copper rings belong to that second framework. They are a passive, permanent, free, ecologically compatible intervention that works with the soil's own biology rather than overriding it, which is exactly why you've never seen them advertised. Let's get practical. Because theory and history are useful, but what most people watching this actually want to know is whether to try it, how to try it, and what to expect. The first thing to understand is the source of the copper. The most commonly used material is standard electrical wire, specifically the single-core copper wire found inside most domestic electrical cable. This is not a recommendation to start cutting up your house wiring. You can buy reels of bare copper electrical wire from any hardware store or online supplier, typically sold by weight or by meter. You want solid core wire rather than stranded, as solid core holds its ring shape better in soil. The gauge most commonly used in observational trials runs between 1.5 millimeters and 2.5 millimeters. Thicker wire releases ions more slowly as the oxidation surface area relative to mass is lower. Thinner wire oxidizes faster, but may degrade within a single growing season. A 1.5 millimeter to 2 millimeter wire gauge seems to be the sweet spot for a ring that will remain effective over 2 to 3 growing seasons before needing replacement. To form the ring, cut a length of wire approximately 30 to 40 millimeters long and bend it into a circle, joining the two ends to close the loop. The diameter of the finished ring should be roughly 20 to 30 millimeters, about the width of a thumb or forefinger. Joining the ends is optional. Some gardeners simply leave the wire in an open spiral rather than a closed ring, and report comparable results. Where you bury the ring matters. The goal is to place it within the active root zone of the plant, close enough for the copper ions being released by oxidation to reach the root environment, but not so close to the main root mass that you risk any localized concentration effect. For most vegetable plants, a position 5 to 8 centimeters from the main stem at a depth of 3 to 5 centimeters works well. For larger plants, some growers use 2 or 3 rings placed at intervals around the root zone in a loose triangle. The rings should be buried before or at the time of planting for best effect. Retroactive installation around established plants works, but the most consistent results in observational reports come from plants that have had copper present in their root zone from the point of first soil contact. Different plant families appear to respond differently, and this is important context for managing expectations. Solanaceous plants, your tomatoes, peppers, aubergines, and potatoes show some of the most dramatic responses in recorded observations, which aligns with the known susceptibility of these crops to soil-borne fungal pathogens. Cucurbits, the courgette and cucumber family also show strong responses. Brassicas, strawberries, and root vegetables such as beetroot and carrot have all been reported to benefit. Legumes are a more complicated case. Nitrogen-fixing plants depend on a specific relationship with rhizobium bacteria in their root nodules. Copper at any significant concentration disrupts bacterial activity, and while the concentrations released by a single small ring are generally considered too low to cause problems, some growers prefer to avoid copper applications near beans and peas out of precaution. If you grow a lot of legumes, it is worth starting your copper ring trials with non-legume beds and observing how your specific soil and growing conditions respond before extending the practice to nitrogen fixers. A note on soil pH. Copper ion mobility in soil is affected by pH. In acidic soils, copper tends to be more bioavailable, meaning it moves more readily through the soil solution and is more easily taken up by plant roots. In alkaline soils, Copper binds more readily to soil particles and is less mobile. If your soil is significantly alkaline, you may see less pronounced effects from copper rings. Adding organic matter, which tends to lower pH over time and increase cation exchange capacity, can improve the responsiveness of an alkaline soil to copper supplementation. This is not a silver bullet. It is one tool in a broader approach to soil health. The growers who report the most consistent and dramatic results are typically those who combine copper rings with other regenerative practices. No-dig or minimal tillage methods, deep mulching, compost applications, and attention to biodiversity in the soil food web. Copper doesn't replace a healthy soil ecosystem. It supports one. There's a reason this kind of knowledge tends to travel in particular communities. The self-reliant space, the homesteading forums, the permaculture networks, the kitchen garden blogs written by people who are more interested in feeding their families than building a brand. It travels there because those communities share a particular value, the belief that knowledge, which is freely available and freely applicable, belongs to everyone, and that the primary obligation of a grower is to the soil they tend and the people they feed, rather than to the commercial structures that surround them. That's a value worth naming clearly, because it's increasingly countercultural in a world where the instinct to monetize every piece of useful information has become almost universal. The copper ring is a piece of that older tradition of practical knowledge. It sits alongside seed saving, fermentation, composting, water harvesting, and the 100 other practices that have sustained human food production for millennia without requiring a purchase order. These practices don't disappear because the commercial world has no interest in them. They survive in the hands of people who care more about growing food than about looking credible to an industry that profits from keeping them dependent. That's not romanticism. That's a clear-eyed assessment of incentives. And there's a secondary point worth making here, which is about the aesthetics of the productive garden. The sustainable self-reliance movement has spent considerable energy in recent years making the case that food gardens don't have to be functional at the expense of beauty. The cottage garden productive space, with its raised beds edged in willow, its climbing beans on handmade bamboo frames, its nasturtiums threading through the lettuces, is a vision of food growing that is as much about the pleasure of the space as it is about the yield it produces. Copper rings fit that aesthetic in a way that a bright blue systemic fungicide spray bottle simply does not. The copper wire itself, especially once it begins to oxidize and takes on its characteristic green patina, is objectively beautiful. Some growers leave a small portion of the ring visible above the soil surface deliberately, as a marker and as a quiet acknowledgement of what's happening below. There's something to that. The best gardens are ones where the methods you use to grow are as aligned as possible with the values that brought you into the garden in the first place. Margaret Hobbs still gardens. She's 73 now, and her raised beds are the best performing in her village. She's told her daughter about the copper rings. Her daughter now uses them on her own allotment in Bristol. That's how this knowledge moves. Not through advertising, not through sponsored content, not through a bag with a logo on it at the garden center checkout. It moves through observation, conversation, and the willingness to try something that costs nothing except the decision to trust what's actually in front of you. You now have the context, the science, and the practical method. What you do with it is entirely up to you. But if you have a roll of copper wire in the garage and a tomato plant that could use some encouragement, you know what to try. If this kind of deep dive into the practices that the mainstream gardening world quietly ignores is what you're looking for, subscribe. There are more conversations like this one coming